So Volker asked me to come in today to talk about some of the work we do in industry using big data and machine learning. So I run a boutique consultancy where we do engagements with companies, Fortune 500 companies, startups, companies on Wall Street, where we specialize in applying machine learning techniques for things like marketing and predictive analytics and a variety of other kinds of very technical operations that they're interested in. I've been doing this for probably 15 years in the Valley, and it's a pretty exciting time. You know, we sort of started off in a startup with my graduate advisor, building these machine learning systems and applying them to ad tech. And over the years, you know, different companies were trying things like, there's a company I worked with called Aardvark, which was acquired by Google, which built a machine learning natural language processing system. We did work at eBay on the search engines. There's people doing this in big pharma, in telecom, on Wall Street. And right now, this is, I would say, the peak of the bubble. I mean, right now, there's just so much activity going on. And so we're seeing what I would say a culmination of over 15, 20 years of research finally being available to just about every company. And I would say probably we're just beginning to see now these techniques moving into traditional business. And I would say within the next 3 to 5 years, this is going to be everywhere. So I'm just going to talk about the last few years of where I've been in the industry and what I've seen, and kind of where I think the industry is going to go by the time when you guys get out of school and start working. I worked a few years ago, in 2011. One of my clients was Demand Media, and Demand Media has a website called eHow. Now, just out of curiosity, I don't know if you ever, at one time eHow was one of the largest websites in the world, top 10 in the U.S. Just out of curiosity, if you used it, does anyone have an idea of what would be the #1 search on the internet, like long tail search, the question you might ask? Any ideas like what the top search would be?
The minute I type how on Google search, it says how, it just pops how to get pregnant.
How to get pregnant, okay. Hey.
The most searched question.
Go out, you should go out and multiply, that's good. The one that I knew from eHow we studied was how to get rid of flabby arms. That was our #1 question. I guess those two go together. So we had used, back in 2011, they asked me to come in to work on the very famous Demand Media patent, which was a patent which essentially allowed us to predict what people wanted to search for on Google. And we were able to develop an algorithm which allowed us to scale eHow to one of the largest websites in the world, and we became the first billion-dollar IPO since Google. And so this is 2011. And I think this is we're sort of considered the firm that sort of kicked off the current internet bubble that we're in. So before LinkedIn, before Zynga, before Twitter, it was eHow. And the idea was that we could measure the demand for search. We knew what people were searching for because we had billions of inbound queries, and then we fulfilled it. And so by being able to front run these queries, we're able to create a massive, massive operation. And now what happened, I don't know if you know anything, if you've used Google or if you've ever tried to optimize a website for SEO, but what happened is that after we did this, we went IPO sometime in early 2011, right around here, and this is the stock price. And then about starting the second quarter in 2011, Google switched CEOs and all of a sudden started changing their algorithms because they realized what we had done. We'd figured out basically their secret sauce. And they implemented a series of algorithms called Panda and Penguin and have been doing this continuously and made a number of other material changes to their search engine. And this caused a huge problem for Demand Media. At that time, the stock price was up in the 40s. Right now, I think it's around $6 a share, and it's never come back up. It's been sort of floating there. Every once in a while, they do better on their earnings. But it just destroyed investor confidence. And part of the story here is understanding that these algorithms are very, very powerful. But they also have, when you start running a whole business based on algorithms, you have a lot of accountability to be worried about. There was a lot of question at Demand Media why, what we could have done. Was it a lack of diversification? Did we not have enough content that was diversified? Did we not have enough sources of inbound traffic? What was it? A lack of adaptation. This change occurred, and a big company like that, it's very hard to move quickly and make changes. And so this had a broad impact on the industry as well. There are a number of other companies, like WebMD, for example. WebMD is a massive website. It was a $1 billion operation, and after the Panda changes, it just completely collapsed. The stock price collapsed. CPC revenues were down a lot. In fact, I think that it was believed that over $1 billion in ad revenue was repriced and reallocated due to Google Panda. So this is a huge impact on the industry. And we see it as a problem of, it's sort of like in Wall Street. You find an algorithm, you corner the market moves on you. And that's just going to happen. And we even argue that Google has fundamentally changed their own business because of this. This is a plot I have of the cost per click, annual and sequential cost per click at Google. And up until Panda, Google always had a positive increase in revenue on cost per click. And after the Panda changes, basically the ad revenue started going down. Now Google will claim, when they never break this out in their SEC filings, they'll claim, well, this is due to mobile, this is due to Facebook, nobody's using Google Plus, things like this. But the reality is, if you really try to search Google, which is one of the dominant marketplaces in the world, and try to understand why people are clicking on things, why they're clicking on your site, where they're going to, no one has any clue what's going on. And it's really not particularly clear why they would see all of a sudden just a huge shift in revenue. And it looks as if, please.
Can we just blame it on Google Glass?
That maybe.
Bad.
Yeah. It's the only product I know you wear, you get beat up for wearing.
Yeah.
So one of the arguments I make about this is that data science, this is a company, Demand Media, is really great at producing content, really great at producing video, very efficient, great engineering, but data science is very different. You start getting into this world, and it's a very, very different type of management you have to deal with. And there's a guy I used to work with at eBay, DJ Patel, who now has gone off to the White House. He's become the data science, the chief data scientist of the U.S. He's now... He has a lot of mantras and sayings, and one of them is he says you need a Spock in the boardroom, meaning that, if you're basing a business on algorithms, and the algorithms are generating 50%, 60%, 80% of your revenue, you got to know how they're working. You have to have an understanding of what's going on because things change. One of the things this is sort of a joke article from the Young, the science is hard. But it really is, you really have to think hard about what is actually going on with your business. You're running these algorithms. How does the market respond to them? If you put something into production, will the market change? Will something happen? How do you predict this? And it's a real challenge to get people to understand, not only are you building something for today, but you have to really be able to anticipate things that are unexpected. And this is a very hard thing to do. So one of the things we see with is, you start getting into an organization, this stuff is very technical, and you're going to see a lot of people are trying to hire data scientists now. Maybe people in marketing want to go and work in data science, maybe business analytics. And you'll see sort of a lot of parts like this. Like there are people who are hackers, and there are people who know math and statistics, and there are people who sort of know business, and there are a lot of these sort of charts on the internet which kind of are trying to help people figure out how to bring these new kinds of people into the organization, put them in the buckets, figure out who they are. This is sort of what I prefer. Do you guys watch Big Bang Theory? It is astoundingly accurate. I have a background in theoretical physics. And so I understand guys like Sheldon. I studied the same kind of stuff. Sometimes he'll talk about we were looking at the Green's function for ionization. I have a paper on Green's functions for ionization potentials. And the thing is, they're all technical, they're all techie guys, but they really are three different kinds of guys, right? Sheldon is a theoretical physicist. He does pure math, he does physics, and he has a certain approach to doing things. Leonard is not. Leonard is an experimental physicist. Leonard is someone who he's kind of the most normal of the group, right? He measures things. He's dealing with the physical world. He uses the things that a guy like Sheldon would invent, but doesn't really dig deep into them. And there's Howard. Howard is just a prototypical engineer. You know, he builds stuff. And when you go into a big company now, there are going to be a lot of guys, like a lot of engineers who are there. And you might think, well, the engineers, they can just build this machine learning system for us, or they can build data analytics and do the data analytics for us. Not at all. They don't. That's not what they do. You know, that's not at all what they do. It's completely different. It's more, a lot of the work you're going to do are going to be more of the Sheldons of the world, the guys who come in and actually understand how to apply some of these algorithms to the actual business problems. And a large problem I see from a leadership perspective is that there just isn't this realization that even though it's all tech, it's all very, very different. The backgrounds are different. The academic. Did you have a question?
Oh yeah, I just wanted to go back to the previous slide.
So this one?
What's a danger zone, which is like.
You know, this is stuff I pull off the internet. I think this is basically saying this is someone who's a hacker who knows computer science and he has some experience, but he doesn't know any math. So what happens, in fact, this is not, imagine this is someone who's like an engineer. They try to build an algorithm. They put it into production. I see this quite a bit. I have clients come to me, well, we hired some graduate student and we had him build an algorithm for us. And we gave him the data and he built the algorithm. And now we put it in production, it doesn't work at all. We have no idea why. Go, yeah, of course. You know, you hired somebody who has no knowledge of what you're doing. And this is very common. They try to, and I think that's what this is trying to say. And it's much more common than you might think. Did you? Oh, okay. I thought you raised your hand. So you're going to see a lot of this sort of, a lot of these kinds when you start getting in and trying to work with people and trying to figure out what do they actually work on. There are a lot of different backgrounds. The tech industry right now has primarily been just software engineers, web engineers. Now we're getting into people who have background in statistics, software, operations research, big data, business, and they work with business people or creatives or as developers or researchers. And these are all different kinds of roles that they play. And so it's gonna, when you start getting into this field and trying to work in data, you're gonna find out it's very broad. And there are a lot of different things going on. And so I want to just talk about, just be aware of that. Now, when I work with clients, sometimes they say to me, we want a process. We need to have a process. What's the process? People in engineering loves process. So I try to give them a process. Process is to think. But this is the process. I say, you try to, first we frame the problem. You talk to people. You try to acquire some knowledge. And then you formulate it. And this is sort of like the high school level science process that you learn. If you were in high school chemistry, did anybody take high school chemistry? Some of you took 1, 2. Nobody liked chemistry. I have a PhD in chemistry also. Everybody hated chemistry. But this is basically like working in the chemistry lab. Chemistry is actually probably the closest thing to data science. I think you formulate a hypothesis, then you go and get some data. You go and collect the data from the organization somewhere. You try to predict revenue. You try to predict how much money we'll make, and then you backtest. Does anyone ever trade on the stock market? They have these tools, and you go back and you run an algorithm, you try to trade, and you see, would I have made money had I traded this? That's called backtesting. A lot of companies do not do this. They'll just take the data, or they just put it into production, and you see what happens. And that's what I say, you put it into production, it just fails. So there really is some process you have to take. The problem is that it's very hard to formalize the process like this. I mean, you can kind of work in small segments, maybe 2-week chunks, and try to do this. But the work is more kind of like this. It's much more free form than you might imagine. It's very hard to solve these problems in a box. Because there's a lot of things going on. You may start working on a problem and you realize you didn't fully understand the domain. You've got to go talk to a domain expert. Then you start working on a problem and you find out, well, I really can't get access to the data because the data's not there. And I think right now, this is sort of where a lot of organizations would like to be here, and they're really kind of here. They're just trying to figure out where their data is and how to organize it and just how to begin. So this is where I would say the industry is now. Maybe in about 3 to 5 years, it will get much more organized and systematized, and people will have a much better understanding of how to apply these methods. One of the things I try to bring across, this is sort of old school Peter Sinjay. Do you guys ever know Peter Sinjay kind of work on how to get people to do systems thinking? When you start applying algorithms to your business, it's very cross-functional. It affects marketing. It affects product. it affects finance, it affects engineering. It's a very cross-functional thing, which is why it is very, very hard to put it in a box and silo it. So I try to think, we really want to try to do more systems thinking. This is sort of the definitions, you leverage interrelationships between data, marketing, and customer, meaning that, if you're going to build a data-driven product like a recommender, you have a Netflix, you want to build a product recommender, the algorithm has to recommend a movie that you like, but it actually has to also make sense to someone who knows something about movies. You don't want to recommend romance movies to people who only watch science fiction. And this, sometimes the algorithms don't always see through that. So it's very important that you have a broad range of people working on these things so they can sort of make sure these things pass the smell test, that they don't just go into the factory line and pop up at the end. There's a lot of knowledge transfer. It's doing science and trying to solve problems is very different than learning, say, technical aspects of solving mathematical problems or trying to write software. You really have to mentor people. And you have to give people, as you begin working, you start working in an organization trying to build these models, marketing models or machine learning models. You have to give people a way to understand them so they can grok what's going on. Otherwise, it just becomes this black box and nobody has any clue what's going on. And you really have to spend the time to share and really get people who are doing research to collaborate with engineering, to collaborate with product. And this is an unbelievably difficult thing to do in most organizations. You really have to make an effort to make sure that all of these things happen. And people are busy. And so this takes, from a leadership perspective, takes quite a bit of planning and work. Now, so I sort of say that data science is different. It's cross-functional. It crosses engineering, product, marketing, and finance. Check the time here. It's autonomous. You usually have to let people just kind of sit and work for a while. It's experimental, and it should, and fundamentally it should be self-sustaining. If you develop an algorithm that makes money for you, it should make money. You should be able to take that money and put it back in the organization. You shouldn't be spending 3 years trying to develop an algorithm and then find out that it doesn't do anything. The whole point of doing this is to generate revenue for the organization. So, sort of where are companies now? In trying to do this. A lot of companies are trying to do this. And I would say right now, they're just struggling to organize their data. You go into an organization, I remember I was in one organization, it was a large Wall Street firm, and they had purchased another firm that went bankrupt. And they had 2,000 databases set up. 2,000, and more databases than they had customers. And we had to come in and figure out, how do we go back and unravel the book and figure out how to, reprice all these assets. This is just years of work to get all this data into one database so you can figure out what happened. Another problem that always happens in organizations, you start working with, you have an idea. I'm going to look at some data and try to predict something. 9 times out of 10, data's wrong. There's something wrong in the data. It's not correct. You didn't look at the data. They say a life not examined is not worth living. Well, data not examined is not actually there. Somebody gives you some data. One of the examples I give is in ad tech. I think it said 50% of all ad tech products are just nonsensical. So they say that you're looking at you're going to run some ads on the internet. The advertiser comes back and says you got this many clicks, this many views, this is the segments, and it's basically flip a coin whether that's correct or not. And these algorithms simply don't they sell things that don't actually work or don't work at the level of accuracy that you think they are. And if you don't inspect them and look carefully, you can really get burned. Part of the problem is there are 2 problems. One is that having more data means more is more. Having more data means you can use simple algorithms. You don't need to use sophisticated statistics, and that's great. But more is also less. Having more data means there's more noise. And you have no idea what is noise and what is not noise. And the effort it takes to figure this out is just Herculean. So one example people are using today is Hadoop. Is it? Oh, please. Go ahead.
The previous message about how data is messy and if it's not example really kind of resonates with me. I work at a company where we work a lot with healthcare data, which if anyone works with healthcare is very, very messy. what do you find is a successful model and kind of where that responsibility lies for data quality? Is, you know, should it be the data science team and the data scientists that are consumers of this data and whose work gets affected? Or should it be more upstream in, you know, maybe like some other parts of engineering that are taking in data from different sources?
You can't expect engineers to know what the data is. That's not their job. Engineers, their job is to put data into Hadoop. That's what they do. They're plumbers. They don't know if the water's poisoned or not. They have no idea. They build the plumbing. And the data scientists, you know, it's hard for them because primarily their role is to try to do, they're going to spend a lot of time, but they're primarily experimentalists. And they really, it's almost as if you have to do a data audit. Every time you do a data science experiment, you have to go back and look very carefully at what you have and decide whether it's real or not. And I think it's an open problem. It's a problem that a lot of companies have because whenever you put data into a system, you have to know where it came from. You have to understand the entire end-to-end process. When I would do experiments at the university, we were doing various kinds of, trying to understand what an experimentalist would do. I'd always go talk to them and find out, let's look at the apparatus, let's see how the data is collected, let's try to understand what was actually done. Because you really have no idea. If someone just hands you some data, you have no idea what you have. Could be anything. Could be made up, could be mistakes, could be errors. And it's just, I would say right now, it has to be at a very senior level. There has to be an effort to actually run experiments that somehow validate what you're doing to make sure that the data in the system is what you think it is. And the problem is that running experiments doesn't generate revenue for you. And so it has to be at an architectural level that whoever the senior architects are who build these systems have to go through and make sure that the checks are there. And right now, the engineering process isn't set up to do this sort of systems level engineering checks.
You want a perspective on that? In my company, I am a sales manager. And literally every week we're talking about
It's a lot of work.
the lack of input from the sales reps. I've got an acute problem. I just ran a report that basically said in one product area we've had no activity in a month and a half.
Wonderful.
And last week, I know there were 9 points of activity that weren't recorded. So there you go.
That's very typical.
Imagine what it is when you have 12 million web pages and you're trying to collect data and you're trying to analyze, or you're running, maybe you're running 10 different advertising campaigns in RTB, real-time bidding, and you're trying to figure out what's going on. And none of the APIs work and the consoles aren't there. This is pretty much where all the large bottlenecks are right now. And the problem is that right now what I see in the industry is they're getting this thing called Hadoop. Does everyone know what Hadoop is? Does anyone not know? Maybe don't know. Hadoop is this, basically it's a system it was sort of sold as what Google does. It's like a Google storage system. And there were some guys from Yahoo. It was actually an interesting story. There's a VC firm, I think it was Excel, that decided to put a team together to build a Google-like storage system. And now it's a very big operation. There's Cloudera, there's Hortonworks. Many of the large vendors provide this. And Hadoop is an internal data ecosystem. And it's massive. But the problem is Hadoop is basically like putting a bunch of boxes in your garage. You get like a giant, or going and put them in your garages. You have like 10 different garages, you put files into boxes and you stuff them into your garage and it just sits there. And so all the data's in one place. So the one thing that people are finding now, one of the solutions is that at least all the data is being put into one system. So you don't have 20 different versions of Oracle, or you don't have SQL Server, MySQL, Postgres, and Oracle running at the same company. At least it's all in the same place. But that's about where companies are now, and that's what I mean by it's a cost center. It's a huge effort. And probably it's going to take them 2 to 3 years to just sort through, and this is coming from guys in the industry who say this, it's going to take them 2 to 3 years just to sort through everything they have and figure out what it is. And then they can start applying analytics. And that's about where we are. Right now, Hadoop is an internal system. I think 90% of the existing Cloudera deployments are internal. A lot of companies are trying to move all their data to the cloud. If you guys know about the cloud storage, I mean, cloud right now, Amazon's currently released unlimited storage. Was it unlimited storage for $10 a month? It just there's a huge war right now in terms of storage. All the prices are basically going to the bottom. Google, Amazon, Microsoft, the big players, and so there are systems like Amazon Redshift, which is a traditional database system, Google BigQuery. The problem is, everybody thinks that the cloud is the future because you don't have to hire people to maintain the systems, you don't have to buy hardware, but there are security issues. And security is huge. I mean, every other day we see a company getting hacked. And so there's a deep concern that if you put your data on the cloud, that it will disappear. And the argument in the industry, and these are people who actually do internal deployments, the argument is that people used to be afraid to put their money in the bank. Who is the very famous robbers in the West? The Sundance Kid and Butch Cassidy and the Sundance Kid, right? People would put their money in the bank, and these guys would ride in on horses and rob the banks. And this is sort of the history of how the bank and the money would just disappear. And then over time, Private Eye company was actually a Scottish firm, and they started tracking the serial numbers on the dollar bills, and they finally tracked these guys down, and then they had to stop it. But early on, when banks were started, they weren't safe at all. And the problem was that the way Butch Cassidy would work is that he had groups of horses. So he would rob the bank on horseback, and then they would just switch horses, and they'd run away. And then you try to chase them, your horse would get tired, and they would just outrun them. And they never killed anybody. They were just very clever. And right now, the industry, there's a huge problem in security right now. Companies are not working together to prevent security. So right now, the cloud is still, everybody thinks it's going to happen, but they haven't really done it yet. There are a number of next-gen solutions that are coming out. One of them you might see coming out is called Spark. It's interesting when you start talking about machine learning versus data systems. A lot of the machine learning work is coming out of academics. A lot of the big companies. So Spark is, you see a lot of in industry right now. You don't see academic systems building database systems. Hadoop is basically an industrial solution. But in machine learning, many of the machine learning startups are academic spinoffs. Spark is one of them. There's a company called Databricks that is trying to produce a cloud version of Spark. It sits on top of Hadoop, but it allows you to run complex algorithms. And so we're finding now that, and so what's happened that Hadoop right now is sort of the data storage system, but it doesn't really do analytics very well. And so you're starting now to see solutions that are sitting on top of Hadoop or that might live in the cloud that are going to do the large-scale analytics. And probably 3 to 5 years, we don't know yet who the winner's going to be. But it looks like right now Spark looks like one of the big winners. Yeah, please.
The impression I'm getting is Hadoop is essentially just a warehouse. But the warehouse management, really making use of the data the companies are keeping on Hadoop, isn't functionality that's built into Hadoop.
No. It's a file system. Oh. It's a file system distributed database.
So everyone's buying into that it's some kind of solution when it's not really a solution for any kind of data manipulation.
No. In fact, the big vendors don't actually do data manipulation in Hadoop. They'll put all the data in Hadoop, then they pull it out, put it into R, and then they do the analysis. No, it's like pulling all the data out of your database to do the analysis in Excel. And it's the same idea. Hadoop is not an analytics platform. It's a data storage platform. And the guys who designed it, they've tried to do analytics in it, but the performance is so, you're starting to see now people like me who actually studied analytics, distributed systems in graduate school years ago, look at this and go, no, this is not how you do it. And so Spark is a memory resident system. So you have to get all the data in the memory. Once it's in memory, then you can actually do something. But that's absolutely the case. So one of the things, there's this guy, again, DJ Patel, says, if you can't measure something, you can't fix it. And I would say that a large part of not only can you have to do the analytics.
He stole that from Drucker.
Is that true? Oh.
It says if you can't measure it, you can't manage it.
Yeah. So he says if you can't manage, it's okay. So that's good. He's a good politician. But being a good scientist is something else. Designing good experiments is really, really hard. And this is sort of what people is like. His talk. I guess this is the Drucker thing. I guess, and now there's the, important stuff can't be measured. It's really hard to measure what is important in the organization, And to actually figure out, as we've seen, to actually figure out, are you actually measuring it? Is it important to you? And is it actually, is it actually what you think it is? And so, a number of people have said this. You try to, various quotes I found on the internet, but a lot of it is that simple metrics may not work. You start working in complex environments. You're working to a world now where you have thousands, millions of customers from different demographics, different cultures coming in using your products, and doing simple things doesn't always work. And doing something complex, well, it's complex. So this takes a lot of effort to really figure out what actually it is you're trying to predict. I'll give you an example. So the problem with things like Hadoop is, I think the buffet is that people have Hadoop, everything, you give them a hammer, everything looks like a nail. You give an engineer Hadoop, they're going to stick everything in the Hadoop, and they're going to try to do everything in it, because that's what they know.
Yeah, I would actually say in addition to metrics being the problem, I think metrics management is a big problem. A lot of management that I've seen employ the metrics all wrong.
Oh yeah, they don't know what's going on. Yeah.
And the problem is take SF Community, for example. They said, the cure to this system, I guess they had a data scientist come in, they analyzed the records, and they said, okay, in order to make this system work, the buster should be more on time. We're looking at an end-to-end time of 13 minutes, right, from loop, right? 13 minutes per loop.
Oh, okay, 13 minutes.
And it took them like 2 days. It took the bus drivers about 2 days to figure out what to do. They just started blowing past the stops, right? So they just wouldn't.
Sure, you're gonna make 13 minutes. Just don't pick anybody up. We can get 13 minutes.
They're actually penalized if they don't make their 13 minutes.
Of course.
But they're not penalized if they skip the stops.
Now, this is actually a good point.
The second time they get dinged, they figure it out. They say, okay, I'm just going to blow past all the stops. And they always made their number after that.
It's a good point of understanding, so I want to talk about, if we have time, about externalities. You start designing an algorithm. It's sort of like this. This is a good example of leading into, and I'll get to your question in a second, the cult of the algorithm. We create this algorithm, and we think it's going to anticipate your needs, what it's going to do, and you don't really anticipate what the side effects are. You can't just put something into production in a living dynamic system and not expect the system to adapt to it. That's crazy. And this is what I mean by you can't just hire someone, hand off to them and say, do this, and then expect something to work. And it's exactly a failure of leadership. You had a question?
Yeah, kind of on the simpler lines. How do they stay relevant in such cases? They take time to, figure out how to measure the problem and all that. So how do they stay relevant? Because we are always running behind. And that somehow does not work in data science, right? They have to figure out the problem beforehand. They have to anticipate.
Well, I would say the problem is a leadership issue. These are things that have to be part of the culture of the organization. You can't have someone do your homework for you. And that's kind of what this is, right? Remember, I always ended up doing homework for people. Everyone made me do their homework for them. And you can't do that because you don't learn anything. You got to have people in the organization who are actively thinking about what's going on all the time and are driving the process from the top. And it becomes a problem when you try to bucket these things off and you're not actually thinking deeply about what the side effects are or what the externalities are that are going to affect you. I actually have here's my page on this. The idea that it's completely ridiculous. It's illogical. You put something, you set it be 13 minutes. You don't think anything else is going to change, and that's just ridiculous. And that is just typical of trying. We just see so much of this. A good example is Zynga. 2010, Zynga is the best company ever. It's our greatest investment. And of course, it was ended up being a disaster. And what happened was, you're running a company. Basically, Zynga was a gaming company running on the Facebook platform. And eventually, people, the market shifted, and they didn't adapt, and they just died. And there are a lot of risks. One of the risks we talk about is the idea of trying to run a business on one marketplace. One of the things we found out was the lesson from demand media is that assets, algorithms can be actual assets. They can be assets on the books. So you think about companies now. Look at what's the number one taxi company in the world now? Uber. They have no assets. They have no taxis. What's the number one hotel company in the world? Airbnb. They have no inventory. You know, these companies are built entirely on algorithms and apps. You know, essentially, you know, Airbnb is essentially matching algorithms. You know, how do you match one person to another? You know, how do you match a driver to someone who wants to be driven, or someone who wants to rent a house to an Airbnb property? So we're moving to a world where we're starting to see a lot of this now, where we're flipping, where now instead of owning compute resources, you rent them on the cloud. And your algorithms now become the assets of the organization. These are the things that are, they say, any tangible or intangible, anything that is tangible or intangible that is capable of being owned or controlled to produce value, and that is held to have positive economic value. Well, the problem is you own it, but you don't control it. And that's the thing, that's the great paradox. You know, if you're running SEO on Google, Google controls it. And so you have some control, but not really. So is it an asset or is it not? And this is one of the big questions that's going to come up. What if you have a pricing algorithm for Airbnb, or a matching algorithm for Uber? You know, these things are now seeing more a recommender system. You're Macy's.com, and you want to recommend products to people on your website. Well, that could generate, Macy's, I think, online maybe generates $1 billion in revenue. A good recommender might generate 50% of that. That's $500 million on one algorithm that some guy wrote, you know, some engineer put it in production. So this is so one of the solutions people talk about, you know, to this is the other problem is being transparent.
Like amoral algorithms.
Well, there are a lot of people now in journalism, for example, we're trying to figure out what these algorithms are doing. You know, are they algorithms, are they discriminated against you? Are they unfair to you? Are they being biased? And it's not like it's a person. It's just an algorithm, but it's doing something which has a negative impact. And an example is one of this, an article I give where people thought Facebook that their friends were intentionally not showing them stories. You know, they weren't seeing the stories. Their friends were hiding it from them. They didn't understand that it was the algorithm on Facebook that was deciding what to show you and what not. It had nothing to do with your friends not liking you. But this is not, you know, and it turned out that, you had a question?
Yeah, I had a question. Like, you know, we just talked on the previous slide about how if companies are running on someone else's platform, basically, there are companies which are running on search engine optimization for Google or on Apple. So I understand that, you know, if you base your business on some other company, the moment that company changes or destroys, you get affected. But at the same time, isn't it true that, like, there is a specialty for a company? If you don't operate, you just pick up that specialty from some other company. So for example, if there is an IT firm and they do not specialize in, let's say, making a product, they just depend on some other company to give them that product. And obviously, the moment that company decides to change or that company gets affected, the product for this company gets affected as well. But isn't it also true that if this company bases all its intelligence and money and investments in making that product, when is there time to do that original work?
Well, the problem is that do you have a diversification of customers? All of their traffic was coming from Facebook. They had no other source, which means Facebook could put the squeeze on them. Well, we want, you know, just squeeze them and squeeze them and squeeze them until they go away. And so they're, you know, they're gone. So you have to have, when it comes like to the ad space, for example, there are a number of companies which are trying to compete with Google. I mean, not so much Yahoo and Bing, but companies like Outbrain, which allow you to bring traffic in from other sources. And so you have to have some diversification of how you're acquiring customers and how you're generating revenue. Otherwise, you know, one of the other players might just switch. And the thing is, in a physical world, usually people don't just stop producing. They don't say, we're going to turn off our factory and go home, right? It takes some time, unless the factory gets blown up. Or, you know, it burns down. But the algorithm can change like that. You know, you walk in tomorrow and you've just lost 50% of your revenue and you have no way to get it back. And now you're on the hook for $400 million in debt. So I think that's really the issue we see. And the problem is that so many now in the industry, you have places like Apple, like Google, like Amazon, which basically control everything. You have no other source. You can't go to another producer. You can't go to another company and have them manufacture it for you. You have nothing you can do. You're gone. And I think that's really the they talk about these companies really being monopolies of the markets. That's the problem. You're basically at their mercy. If they decide they don't like you, that's it.
10 minutes by the most.
So I guess we can close up. Do you have other questions? Other people have questions they might want to.
So Charles, the world's future is back to brick and mortar?
No, I think the future is deep learning. The future is really scary. There are these, the machine learning algorithms now can do things like, you can produce recommender systems, you can predict what kind of music people listen to, you try to detect fraud. But, and these are things you're going to probably see in 3 to 4 years every company will be doing. These are things you can get off the shelf now. There are various companies now that offer machine learning as a service. What's really amazing now in the past couple of years have been these deep learning algorithms that have come out, which are actually based on some very subtle ideas in theoretical physics.
Would you explain machine learning, how you conceive of it, for just a moment?
By machine learning, I mean algorithms that operate on large amounts of data that can predict things. So like the Netflix recommender is a machine learning algorithm. It figures out what movies to recommend to you. Pandora or Spotify figures out what music it thinks you want to listen to and sends it to you. And as we move more and more to mobile, we need to have algorithms which kind of predict for us what we want. And these are algorithms that learn from your behavior and then try to predict what you want to do.
Are the algorithms really clever, or should we just not be offended by the lame movies that Netflix recommends for us?
Well, it's...
Seriously?
It's getting better and better. It's right now. I mean, the problem is that many of these algorithms have been used in ad tech. So in ad tech, it doesn't matter if somebody shows you a spammy ad, you don't click on it. As long as it's not too spammy, you still use it. What happens is when these algorithms start getting out in front of customers and it affects the customer experience, then there's a problem. So you may find you put a recommender system on your website, or you recommend things to people in a store, and if you recommend things that are just bad all the time, they'll stop coming in. But if 2/3 out of the things you recommend for them are okay, they'll probably keep coming in. They sort of expect that it's not perfect. And I think there's a trade-off between how much we're willing to tolerate in terms of something not being really good and how much value it generates for us. But yeah, the deep learning stuff is amazing. I mean, they have systems now that were released that can watch a video and can classify any sport. Is it basketball, gymnastics, football, soccer, lacrosse, cricket? It just knows. And it can, so these systems are getting more and more sophisticated. Probably, in the next 5 to 10 years, you're just going to see just amazing things. Like the Skype translator to me is amazing. Have you seen this? They're building a system. You go on Skype and you talk, and it just translates for you in real time to the other person. And probably within 5 years, and it's good. And so I would expect within 5 years that will be everywhere. That basically there'll be no barriers to language. Yes?
Is there a practical way to develop an algorithm which takes into account anomalies and knows how to probably filter out noise? Is there a practical?
It's actually very hard. Anomaly detection is very, very hard for 2 reasons. One, most of the software that exists now in the industry is based on very simple mathematics, and so it can only detect a few basic anomalies. And to develop a custom algorithm requires an R&D team or working with academics. And so it's a lot of effort. This is like a year or two, a graduate student working on this to really flush it out. And most companies, even startups with major funding, simply do not have the technical staff or the capacity to work through the mathematics. And the other reason is it's subjective. What one person thinks is noise, another person may think is signal. So there are a lot of people trying to do this. I mean, the biggest problem right now is in fraud detection. I mean, there are basic fraud detection. If you have your Wells Fargo credit card and somebody uses your credit card and it's in another state, they can sort of detect automatically, well, you usually don't buy things outside of this zip code, and it flags it. But you start looking at like fraud detection for hacking banks. There's so much money in that it's very hard for companies to really keep up on trying to figure out who's actually a legitimate player, what is actually legitimate network traffic and what is not. So it's a hard problem. There are simple solutions which can be very effective, but developing something custom is very, very expensive.
I think we have time for one more question.
Sure.
Since I would say big data is going to be the future, and apart from the data itself, the source, what are the main challenges do you think you emphasize for this big data? And also, having said that, if algorithms can give answers to most of the things, where is the role of intuition? And when I mean intuition, this is something kind of which you gather by your experience in a particular field. How is that going to play a role in it?
Sure. So the question is, what is the role of big data in the future, and how do algorithms and intuition interplay? I would say that one of the hardest problems you have a data system and you want to make a predictive algorithm, we have to test it. How do you know if it's good? And you have to give it to people who have the intuition, who can judge it. And it's critical to set that up in a way where you can actually make the judgments and it's hard to actually find people who have the right intuition to actually be able to score the algorithm and say this is good, this is bad. But having these people is critical because you can't really develop algorithms that work unless you have humans look at them and score them. I think Google probably has 5,000 staff, contractors who score their relevance to make sure that the results that Google is seeing that it shows are actually relevant. And it's not obvious that there are humans inside doing this. And there are entire companies, which are called Mechanical Turk companies, which provide services you may be able to hire 100 people in the Philippines or in Thailand or in India to actually look at the results of something and score it to see, does this make sense or not? And the trick is, finding people who have the right intuition are expensive. And so having and getting them to actually do the judgments and work with you is very complicated. So it's a real management challenge to find just the right amount of intuition to actually do the job and actually make it cost effective when you're trying to develop algorithms at scale. That's my answer. Okay.
All right. Thank you very much for coming.
Thank you.